Good morning, mathematicians. We're back playing the lean game, and maybe I'll actually finish this level today. That's the plan, anyways. Yeah. Hope everyone's planning a very mathematical weekend for themselves. I'm definitely planning on hunkering down. You can see here in the background, there's some interaction about my lean game playing with Professor Kontorovich on X, and so now I think I'm going to interview him. I asked if he would want to be interviewed on the channel, and then by chance last night I happened upon his lecture series. Hello, Serene. I happened upon his lecture series on analytic number theory, and I was watching some of those videos. Yeah. Okay, so let's prove some things. Let us prove some things. Analytic number theory is cool. It's maybe I don't know as much about it. I don't know as much about it. I mean, that's not entirely true. I know a little bit of like Tate's thesis type stuff and whatever, but I definitely feel, um, yeah, I definitely feel uh, that it's a sort of weak spot of mine. Um, and actually, part of what um, inspired me to look at it, and then last night I was also looking at before I went to bed. I was looking at Julian Havill's book on gamma, which I've recommended a million times on this channel. It's amazing, and as well as Dietmar's book on automorphic forms. You've been working with your prof on a paper on analytic number theory. Wow, very cool. Very cool. What kind of stuff? Yeah, the stuff in Kontorovich's video was well, he was talking about like integrating kernels and Poisson formula, and hinting at like trace formula type stuff. But I also yesterday I was tutoring someone, and in their number theory course, they had to prove some things about providing estimates um, of the pi function of the primes less than x, and I've never done any sort of playing around and bounding with that before. And then yesterday, um, I sort of worked out a proof for the student, and I was like, wow, this is really cool, actually. And I saw some logs up here, and I was like, oh, okay, there's where the log joke comes from. Your prof was sad because he said analytic number theory is kind of dying. I'm very suspicious of that claim. Uh, I mean, L functions are everything, right? I mean, I guess it depends on what kind of analytic number theory, what he means by analytic number theory. Like, is Gamma like a popular nonfiction or a math book? It's a math book proper, but it's not. It's not like as serious as a textbook. You know, there's a lot of you can see there's a lot of exposition. I mean, some textbooks have a lot of exposition, but it's definitely peppered in with like a lot of history and commentary. But then there's also like serious math, like you're talking. Oh, here's like analytic continuation of the Riemann zeta function and stuff. So yeah, I can't recommend this book enough. It's appeared in an episode of What's on My Shelf. I know I've talked about it on stream many times. It's just incredible book, incredible book. So yeah. Okay. Anyways, let's do some math. You recommend diving into the theory of Dirichlet series in general. Yeah. Yeah, I'm really there isn't, I don't know if there's exercises. I don't know if there's exercises, but there's certain things in the book where maybe there might be some computations that aren't, every detail is explained. So there's definitely room for you to do some of your own thinking and computing, and possibly looking up stuff in other books. Yeah, I mean, there's a whole appendix on complex function theory. So I don't know. You should check it out. Everyone should check it out. It's a very good book. Um, yeah, I mean, I would. We talked on stream like a week ago about like Deerschley, not Deerschley. I haven't read Apostle. I should get Apostle. I know I should get Apostle. But we're with what Arton's conjecture. I'm very intrigued by Arton's conjecture. I'd love to know more about Arton's conjecture one of these days. Okay, where are we here? Um, oh right, we were stuck trying to unfold. We were stuck trying to unfold this absolute value. We were stuck trying to unfold this absolute value. Ugh. Like, I'm just so sure it used to be norm num. Did it work this time? No, it didn't. Okay, what is it yelling at me for? Norm num didn't do anything. Field simp didn't do anything. Yeah, that didn't do anything. I didn't want to do that. Linarith? I mean, Yeah, abs neg and abs add though, but norm num would explicitly need a hypothesis that the contents of the absolute value are non-negative. So maybe we need that. Maybe can normalize numerical constants and functions of them. Oh, so maybe we need to prove that the thing in here is non-negative. Maybe we need to prove the thing in here is non-negative. Okay. All undergrad analysis books are isomorphic? I don't know about that. Norm num is the sound you make while eating pie. Yeah. Yeah. Okay. Okay. So I need to prove that that's bigger than 0. So, Field simp did something. Try ring NF after that. I don't think ring N. I think that's just gonna rearrange the interior. I think Arad's right. I think I need a proof that this is positive to combine it with norm num. So I want to show that's bigger than 0. I want to show that's bigger than 0. So I'm trying to do it in my head here. That is a very fun exercise, Arad. Sorry, so I'm trying to show this is bigger than 0. So I'm trying to show yeah. I mean, clearly What do I want? I want have how do I want to write this? N plus 1 minus n is bigger than 0 by, I don't know, will bound do it? Yeah, that seemed to work. Nice. And then I guess I want that. I don't have that little n is positive, right? Oh no, I do have that. Okay. So then I want to divide through. So I should give it a name so it doesn't give it a stupid name for me. You think on Reddit it gets solved weekly? Have A6. These naming conventions are so bad. I'm so bad. Okay, this will be 0 less than n plus 1 over n minus 1. And now the question is how to do this one. Oh, the stuff in the absolute value. Oh, you're absolutely right, Knock. You're absolutely right. I'm doing this the hard way around. I am doing this the hard way around. You're absolutely right. Okay, hang on. Field simp, ring NF. Yeah, what if I hit it up with both of those? Nice. Okay. Awesome. Right. And now I can norm num this with, I think I have the hypothesis a pause. No, didn't like that. N pause. Knock, you're a lifesaver. Nice. Okay. And now I proved this, right? Not quite. Not quite. I have the right things here, though. I could just field simp it or something, right? Maybe not. I probably need to give it more info. Oh, okay. It said something. Okay. Yeah. I guess I probably need... I don't have anything that compares epsilon and n, right? So I guess I want have a 5... have a 5 and the real number is... I hate that it made my goals disappear there. What did I want? And the real number is 1 over epsilon is less than this by linearith. Okay, show me the other things. Yeah, here we go. HN and A25. Something's wrong. Nope. Okay, that's okay. It was kind of a slow morning here today in the lean stream. Okay, great. Now that I have that, I guess I could field simp at A5 and then simply apply A5. And that ought to do it. Nope. I think I'm slick, huh? Oh, don't tell me. Oh, for love of God, don't tell me because I need to somehow. Yeah, I need to commute epsilon and n. Um, what do I do? Do I re what do I do? A rewrite or something? Uh, like how do I just commute two variables? So surely that's why it's yelling at me, right? Uh, what if I ring NF it? Does that do anything? No. At A2? What am I doing? What am I field simp at A2? What? A2 is just this inequality. Hmm. Like ring NF at A2? Uh ring NF at A2? Oh, to swap what I don't understand. What would ring NF at A2 do though? Yeah, maybe just an ordinary field simp. No. No, no, no. Uh I don't know. I don't know. Like this is weird. This is such a weird place to get stuck at the end. Uh I don't know. Rewrite with A5 somehow? Uh I don't know. Yeah. Uh this is weird. How to commute two things. Um okay, what if I did do a ring NF at A2? Maybe you can have. Yeah, I guess you're right, Locke. Um, ring NF converts equations into some predefined form. So if you have two polynomials that are same up to an order of monomials, ring NF should convert them. Okay. Not sure about the. I don't think I have Malcolm though. Like I only have a limited bag of tactics here. Yeah, yeah. So no, but thanks for the suggestion, anyways. Um, so oh, let me. I didn't want to erase that one. So no, maybe Locke is right. Maybe I need like a have a6. Um, is that epsilon times n the real number is equal to n the real number times epsilon by I don't know, field simp. Okay. And then I can apply A6. No? Oh, rewrite probably. Rewrite. Sorry, rewrite A6. Rewrite with A6. No. No, it didn't like that. Didn't like that either. Really? Really? What if I... Is it because the order's the wrong way around or what? Oh yeah, I need to do what? What? I need to do the arrow? No, what is it? Like what is it? Left arrow? There we go. That should work. Yes. Okay, and now I can apply A5. Holy smokes. Holy smoky. There we go. Yeah, when A equals B is not the same as B equals A, am I right, gang? Nice, we did it. I'm not caffeinated enough. I need to have more of a freak out so I get clipped and passed around Twitter again. Let's see, what time is it? How much time have we spent today? 21. Okay, I'll play a little bit longer. Ooh. I almost closed OBS. Sorry about that, gang. Okay. What are we doing? Determine that the limit of the sequence. Determine what the limit of the sequence is and prove it. Ooh. Oh, sorry. I don't know why I said ooh. For a second, I was thinking the sum of these terms, and I was like, okay, that's a step up in difficulty. I guess we'll have to go look up the proof. Yeah, but you're going to be learning vector calculus in physics this semester, so you're picking up geometric calculus. Oh, shocking, Locke. You picking up geometric calculus books to stop yourself from going from the dark side or give in. Why not give in and do something useful for the real world? It's also an option. Wait, we're supposed to... Wait a second. Yeah, okay. Let's see here. There exists an L, so, okay. No? It says there exists, right? Don't we need to... Surely we need to choose L. Or what? No. It's just U0, right? No. Choose 0? Choose 0. No, U0 worked. Oh, it worked. Oh, it was just yelling at me because of unsolved goals. I see. Okay. And then let's intro and intro and great. So we've got epsilon. Okay, there's stuff useful here about the rule. We have yet to learn about dealing with the square root function. So see if you can be even lazier in your choice of parameters. If you know that n is bigger than 0, then you can prove that n is bigger than 1. That is, n is bigger than 1. Excuse me? Excuse me? Uh, uh, okay. Okay. Good morning, Ken. Ooh, that's an interesting idea, Knock. But I think we would have to prove. I think we would have to prove that the limit of the product is the product of the limits, and that would be more involved. And it would be worth doing it that way, of course, if we were building things up in the lean math library right now. But we're in the restricted world of the real analysis game. But you're right. Okay. Um, hmm, 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 hmm. Okay, so we can get that n is bigger than 1. Sure. Why do I want that exactly? Yeah. Hmm, hmm, hmm. I should be writing this out on paper here. I'm not going to do it in my head. I'm not going to go full Neo Matrix mode this time. Let's see here. So, what are we doing? This is our sequence. I've got epsilon bigger than 0. I want to prove that 1 over n squared is less than epsilon. Go mutative algebra. So right, we don't have square roots yet. I mean, if we did, let's think about it. If we did, I would want my n to be bigger than 1 over epsilon. Do we have the ceiling function yet? Do we have the ceiling function yet? No, we could do, but we can use Archimedean property. We can use Archimedean property, but I want, okay, right. So I want to take my n bigger than n, and I want that n to be bigger than this. So that's n squared bigger than this. So, right. So, Oh, hang on a second. I'm getting an idea. Hello, Milesman1001. Loved the theorem ranking video. Hell yeah. Especially the part where you tore off all your fingernails. That's what I'm here for, baby. You are here too early, Leo. Yeah, go back to bed. What if you get the m from arch prop? Does n times n work? Yeah, I think so. You're not going to react to a 3-hour video. You could just react to the final, 5 minutes. I put a timestamp where I give the final S tier ranking. Yeah. So, yeah, if we take n bigger than n squared, that should work. Because, yeah. So, okay. So first we'll get arch prop, but hang on. Wait a second. But how? Let's think. How is this argument actually going to go? Because what are we actually going to do? We'll get arch prop to get an m that's bigger than 1 over epsilon. And then we take m to be m squared. No, we could just take n to be... We could just take n to be m. I'm trying to think how would this argument go here. So, sorry, well, we take n bigger than 1 over epsilon. So then little n is bigger than 1 over epsilon. What about... No. What am I trying to do, Leo? Calc 1, yeah. Yeah, we're trying to prove this, but we don't have square roots. We're trying to prove that the limit of 1 over n squared is 0. But we can't, yeah, as n goes to infinity. But we can't take the root of epsilon. I'm just being really stupid right now. Business as usual, am I right, gang? Yeah, okay, we'll do this tomorrow. I gotta go write my thesis. We'll do it tomorrow. I'll just address some of these comments and then we'll go. What are some of your most unpopular opinions? My most unpopular opinions are my tier list video. Some Fields Medal theorem went to D tier. Yes, that's true. I regret nothing. I regret absolutely nothing. Yeah. Bound it against 1 over n and 0. All this made you forget what the definition of the limit is? Good, you don't need it anyways. Oh yes, 1 over n is bigger than 1 over n squared. True. Wait, so what? Wait, why is that helpful? We'll talk about it tomorrow. Go write some proofs. Go compile some code. Can we do that in the real analysis game, though? 1 over n bigger than 1 over n squared? Yeah, absolutely. But for now, I'm just going to say QED.